Hey everybody, my name is Blaze and welcome to our rebooted action RPG tutorial series. Now, in the last time that I attempted this, I ran out of time and eventually I lost interest. But now that we've restarted it, I'm determined to finish it. So what we're going to do today is we're going to get started with an actual project. And unlike I've seen a lot of other tutorials making RPGs in GameMaker. Most of them tend to stick to just the programming, which is fine. There's nothing wrong with that. But what I'm going to show you guys is not just the programming, but also the visual stuff as well. So we'll be doing more than just programming here in GameMaker Studio 2. We will also be creating all the character sprites, all the environment sprites, and we may just do cutscenes and things like that towards the end of the series. But definitely you'll be getting spriting tutorials as well as games development or games programming here in GameMaker Studio. So let's get started because I've already been talking for about a minute. Let's start with a new project here in GameMaker Studio 2, and we're going to use GameMaker language. Give your project a name. I'm going to call mine Tutorial A RPG for Tutorial Action RPG. Save that, it will create it. The first thing that you're going to want to do is go into options and go down to main. Now change your game frames per second from 30 to 60. Make sure you click the apply button and click OK. Now that's done. Our empty project will have nothing in it for now, but we're going to change that. The first thing that we're going to do is have a look in here. This is our room 0. I'm going to change my room name depending just so that we have a few extra rooms to play around with. So I'm going to call mine room 001. Press enter. I'm also going to change the width and the height of the room from 1024 to 640 by 360. This is just to make sure that we keep our demonstration within a smaller sized room. Now we're going to actually get into the game development part of it, and what we're going to do first is we're going to create a sprite and give it a name. I'm going to call mine View Collider, mainly because this will be the basis of most collisions in the game. In fact, this is my average size tile. I recommend that you guys decide for yourselves what your average tile size or average collider size will be. So average being maybe your main player will be of average size, or maybe an NPC is your average size. Something that you can refer to that will always be in the game. And generally something that's either 4, 8, 16, 32, 64, 128, or 256 if you really wanted to go with a big sprite size. What I'm going to work with today is 32 by 32. This is pretty much going to be my average size, height and width. But what we're going to do now, once you've decided what your tile size or your sprite size is, mine is 32, you can choose whatever you want. I'm going to change that, I'm going to edit the sprite, and I'm going to add in a 1 pixel border around our object. Actually, you know what? Let's make it a 2 pixel border just so that we can actually see the whole object. And we're going to change our origin from top left. Well, I'm going to change my origin from top left to middle center because we are moving in a top-down fashion. It makes it easier to change the sprite or calculate everything from the middle of the sprite. If you're working with a platformer, you might go middle bottom, or bottom center, but for now let's just stick to the project that we're working here. And now we're going to do two things. We're going to create two objects. I'm going to call mine obj player, and I'm going to assign a sprite to it so that we can actually see it in the room, and we're going to assign a collision mask. Get into the habit of assigning collision masks because these are pretty important. There are going to be parts later on in the series where we will deal with objects that have colliders, but they don't exactly have a sprite. So that is something to consider. All right, so make sure you get into the habit of assigning a collision mask for objects that do need it. Now we're going to duplicate this, but we're going to change the name of it from object player 1 to object collision. But that's really all that it needs to do. We're not going to do anything else with it. So let's go back into the room here and let's put these two objects inside of the room. So we have object player over here and we have object collision over here. Cool, awesome. Let's save the project and let's play it. Nothing is going to happen, but if we press any keys, nothing really happens because we haven't done anything. So what we're going to do now is we're going to go into the add event. We're going to create our actual object here. Add a create event, and you don't have to have a description, but it pays, especially if you're working in a team, it pays to have a description for each event, because I honestly think that it will help people navigate your project. So here in the description, I'll just type initialize. You don't have to have anything here, but we're going to initialize our object. Now we're going to need 3 variables here. We're going to need x-axis, which will control our left and right movement. So left and right. Left, right movement. And basically what I'm writing out right now are called variables. For those of you who don't know what I'm talking about, variables are basically areas in memory that have been set aside for these small pieces of information. So if that went over your head, that's okay. It's really just a matter of being able to know how to use it at this stage. So we're still very early in the project. So you don't really need to know what it is exactly. But essentially a variable is a piece of memory that's being reserved for this particular object or for this thing called x-axis. And we're setting it to 0 so that we can change it at a later stage. We usually set these objects unless they're going to change. We're usually going to set these objects or these variables to 0. Since there's no null variable, there's no null keyword here in GameMaker. Now y-axis will control our up and down movement. And we're going to need one more variable. This variable is going to have a specific number that we're going to change at a later time in the video, but for now we're going to call it speed. Be careful how you write this because there are plenty of different built-in variables, as noted here in the color green. For me, might be different for you guys, but here in green we have a whole bunch of built-in variables. The one that you need to be aware of is this one here with lowercase s. So make sure that if you're copying me, that you copy the capital S at the start. Don't use lowercase. And we'll default that to 1. So how fast we move. It's pretty self-explanatory, but for the benefit of the people who aren't confident with their code, this is what we're going to do. So how fast we move. Simple. That's pretty much all that we're going to need for now. We're going to add another event, this time a step event. And I'm going to show you guys a very common practice for beginners. And what it is they will write keyboard check. Let's just use the arrow keys for now. VK left. This is something very common, right? If keyboard check VK left, oh my gosh, x plus equals negative speed. And let me just copy this for the sake of saving time. VK, instead of left, we're going to go right. And we will do that. And then we'll copy this. And then we'll go VK up. We go plus equals Y, VK down. That's fine. Like, I mean, this is an acceptable way, that what you're seeing right now. And it works, more or less. But you can see if we're moving up, down, left and right, we move kind of slow. But if we move on a diagonal, we move pretty fast. We get a speed boost. If you're familiar with your maths, your high school maths, this is all reliant on something called Pythagoras Theorem. Look that up. If you put into your A and B, basically your X and Y for your Pythagoras calculator, you will get the C value will be 1.4, 1.14 or 1.41, something like that. So basically you're getting almost an extra half of the speed. So what we'll do instead is we'll go x-axis and we will go keyboard check vk right minus keyboard check vk left. I will write this out first and I will explain it afterwards. So y-axis, we're going to do the same thing. Y-axis equals keyboard check vk down minus keyboard check vk up. Now what this does is both of these pretty much do the same thing actually, but they just change depending on which axis we're using. So either we're going left or right or up and down. So with the x-axis, what we're doing is whenever you're holding down a key, it will return 1. If you're not holding down a key, it returns 0. So what you need to do is, since right is positive on the x-axis in GameMaker, we need to check this first. So if we're pressing down the right key, but we're not pressing down the left key, it will return 1. Now here, this minus function is obviously -1. All right, so if we're pressing down the left key, left is negative on the y-axis, it will return -1 because of the minus here, right? So if we're holding down the left key, but not holding down the right key, then we will go -1. Let me show you exactly how that works by going down here and saying show debug message string. This is not part of the tutorial. I'm just proving a point here. So x-axis, and this is a good way to debug your actual values. So here we go. We're going to check the x-axis now. So I'm holding down the right key. It returns 1, but we're not moving. So don't worry about that for now. If I hold down the left key, we go -1. If I'm holding down both left and right, we go 0. And if I'm holding down neither key, it goes to 0. So you can see, you saw there in the output section exactly how it worked. So hopefully you understood that. If you at any point don't understand anything, then feel free to ask questions. I will answer them to the best of my abilities. What we're going to do now is we're going to add a variable direction. Now what this var keyword does is it makes sure that whenever we have this variable here, it stays within this step event. It can't be changed anywhere else. Okay, so just keep that in mind. The var keyword essentially just keeps it within a small area, whereas this is not a global variable, but it's accessible by all the scripts that we attach to the player, whereas var, we can't do that. So just keep that in mind. What we're going to use is point direction, and what point direction does is it gives us, as it says, a direction. So we need 4 arguments. We need an origin for x and y, which we're going to use 0 and 0, right? The top left corner of the room. And it needs a destination, or rather a direction that we're going to move. So we need to move in x-axis and y-axis. It's already been given to us. X-axis and y-axis. Cool, awesome. The next bit that we're going to put in is var length. And this time we will use the speed variable. So speed multiplied by, and this is a little bit complicated. So let me write this out first and I will explain it. X-axis not equal to 0 or y-axis not equal to 0. I have complete confidence that whoever watches this will be able to, or should feel comfortable asking questions. But essentially what we're doing here is we're taking our speed variable, which we can change, by the way, and we're multiplying it by whether or not x-axis or y-axis is greater or less than 0. Okay, so if we're holding down any of the keys, then this will return whatever speed it is, either positive or negative, just to keep that in mind. I will show this once we actually implement it. So what we're going to do now is we're going to manipulate the x-axis again. Actually, you know what? Let's debug that. So let's show debug message, string, and length. Now we can still use length here because it's all in the step event, but we couldn't use it if it was anywhere else. Keep your eye here on the output down in the bottom. Hopefully I'm still in time because I really do want to keep everything simple. So there we go. Everything returns 1, right? Because, well, we're moving, and that's really all it's concerned about, whether or not we are moving or not. So it returns 1 because our speed is actually 1. But if we change that to 2 or 4, actually I'll just leave that there. I'll comment that out for now. I'll prove a point later. For now, let's just keep going. We now have the x-axis here, and we're going to change that again. So now that we've got our keyboard checked and we've done all these things to it, like these manipulations to it, we're going to change it again directly. So now we're going to take length direction, length dir x, and it takes a length and direction. We already have those two. So let's put in length here and direction at the top. Length direction. We're going to do the same thing for the y-axis. And we're going to copy that. As much as possible, don't copy paste your own code because that's how mistakes are made. The only reason why I'm doing that is because I want to keep this video under 30 minutes or, you know, as close to 20 minutes as possible, and I'm already way into that. So what this does is basically these two lines eliminate that weird move speed boost that we get, that speed boost that we got before. Basically, these two lines eliminate that and make sure that we move at a constant speed regardless of which direction we're moving in. And finally, we go x plus equals x-axis and y plus equals y-axis. This will actually allow us to move. So let's uncomment that. And let's change our speed to be something a little faster. Let's go with 4. I like to keep things as square values. So there we go. We now move at 4, and we can see that we move pretty fast on x and y. But you can see that on the diagonals here, we're moving at the same pace, which is good. That's what we're aiming for. So let me get rid of that line there. Let me change this back down to 1 because the next step is kind of important. What we're going to do now is we're actually going to put in some collisions, some very basic collisions. So what we're going to do is we're going to check if place meeting, and place meeting takes 3 arguments. Okay, so it takes an x, y, and what object we're checking for. So if place meeting, we're going to go x plus x-axis. So remember, it's our x position plus whatever our length is, or whatever value our x-axis is, whether it's 1, 2, 4, 8, whatever speed you're moving at. Since we're not checking the y position, we just leave it at y. And the object that we're actually going to check for is object collision. So we go obj collision. And what we're going to do is we're going to say x-axis equals 0. Now we need to do the same thing or a similar thing, and that should be x-axis. We need to do a similar thing for the y-axis. So we're going to copy that. Well, I'm going to copy that. You guys should get into the habit of typing this out, but time restraints, and I want to keep this within a certain time frame. So instead of checking left and right, we're going to check top and bottom. So y plus y-axis. And then we're gonna stop moving so that we can't move. We can move up to it, but we can't move away from. We can move up to it, but we can't actually overlap it. So let's try that now. Let's see what happens. Let's change our speed back up to 4. Or actually, let's change that to 3. Just so that we can see what happens in the actual game. So here we go, we're moving pretty fast. Good speed. But if you look closely, you can see there's like a small gap between, there may occasionally be a small gap between my player object and that static collider object that we got there. And the reason being because it's trying to stop it as close to the object as possible, but it can't do that given our time frame that we've got for it, because it's moving 3 pixels per step. It's moving too fast. So what's actually happening is it's moved into the object, but it's found that, oh, I need to move back 3 pixels because that's the speed that I'm moving at. So that's why we get that weird 1 pixel gap. To get rid of that, you just do this, all right? While not place meeting, and essentially we're rewriting this code with a slight change. Okay, we go x plus sine x axis y object collision. Okay, so what this does, what sine does, is it returns either -1, 0, or +1. So it doesn't matter what your speed variable is, which is changed up here. Doesn't matter what it is, it will always return -1, 0, or +1. Okay, just to keep that in mind. And so while we've collided, and while we're not right up against it, we are going to move at x plus equals, I think, yes, x plus equals sine x axis. Done. So we've collided. All right, we've collided with something, but since we're not right up against it, we're going to move across. We're going to keep moving across 1 pixel until we are. So once we have come up against it, it will stop us from moving. And that's exactly what we need to do down here for the y-axis as well. So while not place meeting x, we're not checking on the x-axis, so y plus, sine y-axis and obj collision. Now I need to bump that up against there. That works. We need to then say y plus equals sine y-axis. And that's pretty much done. So let's play the game. If you have followed everything right, then you should come up with this, right? We can move right up against the other object here, no problems. And even if we speed up to say 8, just so I can show you guys a contrast, if we speed up to 8, then we should still be able to bump up against it. So no matter how fast you move, I missed the block there, but no matter how fast we move, we are bumping up against it, and we're pushing up against it. It won't move, but we're colliding, which is awesome. Cool, everything works, and that is pretty much the end of this video. So what have we done? Well, we have created a single sprite here in our really super simple game, and we have been able to move and collide with things. So you can have a look at that entire script here. All right, this is everything that we've learned today. So we can now take keyboard inputs, we can move, and we don't get that weird speed boost on the diagonals, so that's a good thing, that's a plus. And also we can collide with other objects. Now if you're wondering what's the point of having these objects, these can be anything in your game. These can be NPCs, they can be enemies, they can be walls. At this stage, we're just covering the absolute basics of the actual game. So later on in the series, we'll go through inheritance, creating enemies, creating loot boxes. All of their collisions will be coming from this object collision here. So that's something to keep in mind, okay? All right. Well, that's all from me, guys. I hope you've learned something. You can just chill out and take a look at that code, make sure everything lines up properly. If it doesn't, or if you are confused about anything that I've presented today for you guys, then don't hesitate to ask any questions. I will do my best to answer them as quickly as possible, but for now, I hope you've learned something. If you have any problems, then yep, you can ask. And something that you guys can do to actually help me is to share this on Twitter, on Pinterest, Reddit, anywhere that you can, if you found it useful, okay? So don't share it just because I've asked you to. If you have found it useful, then I do ask that you guys help me out by sharing this so that other people can learn from what I've got to teach as well. So that's all from me, guys. I will see you in the next video. And for now, just keep making more sprites because we will need that. The next video will be all about sprite creation for your game. So if you're looking forward to that, then stick around for the next video. But until then, that's all from me. I'll see you all later. Bye.